Hi. Welcome everyone to this session. I'm really excited to be here at Devox UK. In this session, I'm going to talk about Cloud Native with Spring Boot and Kubernetes. We're going to go on a little journey from development to production. I'm Thomas Vitale. I'm a senior software engineer at Systematic in Denmark. I'm really passionate about anything Cloud Native, and I like building applications with Spring Boot framework. I'm even writing a book about it. It's called Cloud Native Spring in Action with Spring Boot and Kubernetes. In my spare time, I'm a supporter of open source technologies, and among the other things, I like contributing to projects like Spring Security and Spring Cloud. Today, I'm going to talk about Cloud Native because Cloud Native technologies empower organizations to deliver software faster and in a more flexible way. We use these technologies to build more resilient software, which is available to users even in the face of failures. We want to build software that can scale to reach more users and more devices as well. Just think about the Internet of Things. And at the same time, we also want to optimize costs. So today we'll go on this journey, a cloud native journey from development to production. And we're going to start by building a cloud native application using Spring Boot. After that, we're going to containerize it using cloud native build packs. So we're going to package the application as a container image. And finally, we're going to deploy it to a Kubernetes cluster. Without further ado, let's get started with the first step, which is building a cloud native application. And we'll do that by going to start.spring.io. From here, I can initialize a new Spring Boot project. So I'll choose Gradle, Java. Then I'm going to choose Spring Boot version 2.6, the latest release candidate version. And the application will be called Demo Service. I also want to use the latest and greatest Java 17. Perfect. This application will have a very simple business logic. We'll expose an HTTP endpoint to return a message that can be configured. So as a dependency, I have two main choices, two different technology stacks. The first one is using Spring Web, which is based on the Servlet API and by default uses an embedded Tomcat server. And the other option is Spring Reactive Web, which is based on Project Reactor and the Reactive Stream specification. When we have applications that are really I/O intensive, so when we have operations to interact with databases, with other services, Spring Reactive can really help us build more scalable, more resilient, and at the same time, more resource efficient applications. So I'm going to choose Spring Reactive Web. And the embedded server in this case is going to be native. Then, since we want to go to production on this journey, I also want to add a Spring Boot actuator, which provides a lot of useful and helpful functionality to monitor and manage the application in production. For example, it exposes some endpoints to provide information about the health of the application or even metrics. And I can choose to expose these metrics according to several different formats. For example, if I want the Prometheus metrics, I can even add the Prometheus dependency. And then actuator will expose Prometheus metrics as well. At this point, my application is initialized here. I can generate the project and move to my IDE. I have already opened the project there, so let's have a look. This is an empty Spring Boot project. You can see the main class initializing Spring Boot. The first thing we want to do is defining a REST controller. We want to expose an HTTP endpoint. So I'll do it in this class. Let's call it Demo Controller. And then I want to handle GET request to the root endpoint. Whenever I send a GET request to this endpoint, I want to return a message. Since we are working with Reactive Spring, I need to use reactive data type. So in this case, I'm going to use a mono of string. Mono represents either 0 or 1 value. So you can think of it as a reactive version of an optional. The other data type is flux, which we use when we have collections of data. But in this case, it's only one. So it's going to be a mono of string. The method, let's call it getMessage. And then I can return an object of type mono by saying mono.just. And then I pass a message, for example, Spring Boot on the cloud. This works, so I can build the application, run it, call this endpoint, and I'll get this message back. But it's something that I like to change depending on where I'm deploying the application. And that's where we start talking about externalized configuration. According to the 12-factor methodology, configuration is anything that changes between deployments. So in order to make this message configurable without having to change the code and rebuild the application every time, I'm going to define a custom property. So I'll open the property file, application YAML, and define a custom property named demo message. And then the message will be Spring Boot on the cloud again. This is the default value. This file is bundled with the application. So if I don't do anything else, this is the value that I want to use. But then, since I have now a custom property, when I deploy the application, I can override this value through different ways, for example, using an environment variable or using a config map in Kubernetes, as we'll do later. Once we have this property, let's keep it visible down here. Yes, we want to read the value from the Java code. The recommended way of doing that is parsing that value into a Java object. For that purpose, I'm going to use a record called demo properties. There will be only one field of type string named message, and I want to instruct Spring Boot to read all configuration properties that contain the prefix demo. And then by combining the prefix and the field name message, I'm gonna get access to this value from the property file. The last step is enabling this functionality in Spring Boot, so I can say to Spring Boot to scan my application for configuration properties beans. And this is a bean just like any other Spring bean, so I can take it and inject it into the REST controller. So I can say private final demo properties, and then use constructor auto wiring. At the end, I can replace the hard-coded message with the value coming from the properties message. Perfect. At this point, our very simple business logic is completed, but we still don't know if it works. It's true that it's a simple business logic, but we're going to production, so we want to write and ensure that the quality of our application is really guaranteed. So I need to write some auto test. In particular, I want to write an integration test. So I'll open this other class, which is generated while initializing the project from start.spring.io. And using the Spring Boot test annotation, I can define a setup to spin up a complete Spring context for the application, including the embedded web server by using this web environment option. I'm using a random port because really I don't care which port is used. I'm interested in sending HTTP requests to the application and write some assertions about the result. In order to do that, I will auto-wire a web test client object, which is provided by Reactive Spring. So I can use this one to both send HTTP requests and then write some assertions about the response. So I can go ahead and define a test case here. So we can say, for example, that when we send the GET request to the root endpoint, then we want to be sure that the message is returned, like that. And we're using web test client. I can send a GET request to the root endpoint. Then I write exchange to send the request. And finally, I can get the response back, verify that the status is 200 OK, and that the body is a string, which is equal to Spring Boot on the cloud, which is the default value that we defined in the property file. And I'll run the test. So what I just done is sending a GET request to the root endpoint, exchange is for sending a request, and I get back a response. Then I can write assertions about the response. So I can say that the response status should be 200 OK, and that the body should contain a string equal to this value. And the test is green. So we are ready to deploy the application. To do that, I need to package it. Cloud-native applications are supposed to be standalone, so there should be no external dependencies other than the runtime environment. So in the case of a web application, means that the web server should be embedded inside the application, and that's the default mode in Spring Boot, so we don't need any extra configuration. But I can use directly Gradle or Maven in order to package the application as a jar file. This jar file is a standalone jar that we can run as a standard Java application. It contains everything we need to run the application. So in Gradle, we use the boot jar task. There's a similar command in Maven. And after that, I can say java-jar and run the application like this. And we can also verify that it works. To do that, I'm going to use a utility called httpy to send a GET request to my local host on port 8080, which is the port used by Spring Boot by default, and in particular, the root endpoint. And I get back the message, Spring Boot on the cloud. So let's review what we have done so far. We talked about self-contained applications. And in Spring Boot, we can have applications which are standalone with an embedded server. In this case, we are using native because we are relying on the reactive stack. We have no external dependencies other than the Java runtime environment. And we package the application as a jar that is also called an Uber jar or a fat jar. And then we briefly mentioned externalized configuration. I have used a property file to define a default value for the message that I want to return. But then, since now it's defined as a property file and it's not hard-coded in the application, I can override it via JVM system variables, environment variables, or ConfigMaps, as we'll do very soon in Kubernetes. But in order to deploy the application to Kubernetes, we need to package the application not as a jar. We need to obtain a container image. So the next step is containerization. For Java applications, we have different options in order to package applications as container images. So we can use, of course, the standard way of writing a Docker file and listing all the instructions that we need to build a container image. But we can also use some tools that automate the whole process for us so that we don't need to provide a Docker file. One option is using Jib, which is a tool built by Google to containerize Java applications. Another one is Cloud Native Buildpacks, and it's what I'm going to use today. Cloud Native Buildpacks is a specification. It's a project hosted at the Cloud Native Computing Foundation and defines how to transform application source code into container images. There are a few different implementations of Buildpacks since it's a specification, and the one that we're going to use is Paketo. You can use this same approach for different types of applications, not just Java, but several languages and frameworks are supported. When we use Spring Boot, we don't have to install anything extra because the Spring Boot plugin for either Gradle or Maven, they contain Buildpacks already. So we can directly rely on Buildpacks transparently without installing any additional tool. We have previously built a jar file using the boot jar Gradle task. You can do a similar way in Maven. For building a container image, we have another task, boot build image in Gradle, and then the option in Maven. So it's enough to rely on what we already have without installing anything extra. And the Paketo Buildpacks implementation, which is the one used by default in the Spring Boot plugin, provides production-ready images already. So with a lot of focus on performance, both at build time and runtime, and on security. Let's see how it works. So I'll stop the application that was running earlier, and now I'll run boot build image in order to containerize the application. This task can be configured, of course, in your build Gradle file or in your POM XML. So you can configure, for example, a different format for the image name or passing some environment variables in order to customize the behavior of the Buildpacks implementation. And what I have done in my source code, which is available on GitHub, is setting up an automation in order to run this task whenever I push something new to the main branch, and also publish it to a container registry. So if I pass the publish image argument to the boot build image task, then I can also directly publish the image to container registry. That is what I have already done automatically using GitHub Actions. So the container image is on my Docker Hub registry, and we are ready to move to Kubernetes now. Spring Boot can be run on Kubernetes without any extra or additional changes in your code. It can it supports natively things like ConfigMaps and Secrets. So what we're going to do now is going through different aspects that we need in order to deploy Spring Boot on Kubernetes for production. What I have running in my Azure account is a Kubernetes cluster. I have used VMware Tanzu Community Edition, which is an open source and free project to run and manage Kubernetes platforms. And one of the components that is part of this platform is Knative. Knative is another open source and free project, which builds on top of Kubernetes to provide more developer-friendly interfaces and supports extra features like support for serverless workloads and event-driven applications. So the first thing that we want to do is defining a basic deployment manifest to deploy our application to a Kubernetes cluster. So this is where we're going to start doing a lot of YAML now. So I have a YAML file already here, API version and kind. So this should be a deployment. We want to deploy the demo service application. And we want to have one container for our application, again called demo service. And the image is the one that my automation on GitHub pushed to my container registry automatically. So it's Thomas Vitale / demo service DevOps 1.0. Now I could go ahead and use the Kubernetes CLI to apply this deployment resource. But then I would need to also create a service resource in order to expose the application inside the cluster. And then I would need to create a third resource of type ingress in order to expose the application to outside the cluster, to the public internet. Since I have Knative in my Kubernetes cluster, I can simplify this whole process. And instead of dealing with those lower level resources, I can use Knative. So instead of having a deployment resource, I'm going to have the API from Knative, which is called service. So as you can see, everything else is the same. So from now on, all the changes that I'll apply to this manifest, you can apply them directly to a Kubernetes deployment object also. And you'll find examples in the source code if you're interested in comparing the two results. Yes, so this is a basic way of deploying the application. I'm not going to do that because it's not quite ready for production. The first thing we need to fix is how many resources are used by the container. We are in a cluster where many containers are competing for CPU and memory. So we want to be explicit in how many resources each container needs to run. So I can do that here. I'll define a resources section. And we have two types of resources that we can specify, the requests and the limits. The requests are the resources that are needed by the container to run. So they are the ones guaranteed for the container. And then if there's extra resources available, the container can use them up to the values defined as limits. So we can start by defining values for the memory. For example, I can assign 1 gig each. And then the CPU. Now for the CPU, I want to leave the upper limit unbounded. So that if there is any extra CPU, I want the container to use it. These two types of resources are very different also in the way that they can make your application fail. So let's talk a bit more about how to configure specifically this memory and CPU resources. The CPU is a compressible resource. When we hit the limit, the process is throttled. It means that the application would keep running, but maybe with lower performance. But the memory is a non-compressible resource. When we hit the limit, we get the dreadful out-of-memory killed exception. So the application is terminated. So we want to pay extra attention to how we configure memory in order to avoid these types of errors in production. Regarding CPU, instead, so you can see in my example, I used 0.5 CPU, and usually I use lower values when I'm presenting how to configure these resources. But in a real production environment, I probably wouldn't use that, because it's true that we can scale up, or we can deploy many instances of our applications. But applying lower values of CPU it means that we are not taking full advantage of all the Java capabilities, in particular when we have a multi-core environment. So it's better to have less containers with more CPU than more containers with really little CPU. So performance-wise, you would get better results by leveraging the multi-core capabilities when it comes to Java containers. Having said that, we can move on. So this is the first thing that I think it's really critical before going in production, setting up requests and limits for CPU and memories. The next step is about externalized configuration. I talked briefly about that earlier, but we haven't quite saw how to basically override those values when we deploy an application. And in Spring Boot, we have really different options. So depending on where we are deploying the application, we can providing this configuration from the outside in different ways. I mentioned the basic property files types that we can also override using command line arguments or environment variables. But we can also rely on a configuration service. For example, we could run our own instance of a Spring Cloud config server, or integrate with HashiCorp Vault using Spring Cloud Vault. Then, if we deploy our applications on a public cloud platform, we can use the services provided by the platform itself. For example, if I'm deploying my applications on Azure, I could use the Spring Cloud Azure project in order to integrate with the Azure Key Vault service and get configuration from there. And finally, if we are in Kubernetes, as we do, then we can use ConfigMaps and Secrets. And that's what we're going to see right now. I'll go back to our YAML files. I'm going to add a new file here, configmap YAML. Let me zoom in. This one will have API version v1, and the kind is configmap. The name of the config map will be demo config. And then as data, I can either provide key value pairs or embed an application property files. We're working with Spring Boot, so we are used to work with property files. So I prefer this second option. So I'll write application.yaml, and then I will embed property files in here. If you're using a tool like Customize, you can even automate the generation of a config map starting from a property file. Really convenient. So in here, first of all, I could overwrite the property that we defined earlier, demo message, and saying Spring Boot on Kubernetes, like that. And since we are here, I also want to enable or improve how the application is shut down when it receives a termination signal. We are using Kubernetes. One of the features of Kubernetes is having orchestration and self-healing in place. But when Kubernetes sends a termination signal to one of my instances, for example, because we're doing a rolling upgrade or we are scaling in and out, then the application should not be killed instantaneously. But we want all the pending requests that might be still in process to complete. And we can enable that functionality from the property file to a property called server shutdown. So I can say shutdown graceful. And when a termination signal is received by Spring Boot, then the application will stop accepting any new request, but it will wait for all the current ones to complete. And it will wait according to a timeout that we call also grace period that we can configure as well. So I can say Spring lifecycle timeout per shutdown phase, for example, 15 seconds. Then if after 15 seconds, the application still hasn't completed all the requesting process, then we just terminate the application because it means something went wrong. We don't want to wait any longer. And this is also a critical point when we want to deploy the application in production. So I could write it directly in the application property file bundled in my project, but maybe I don't want a graceful shutdown to be enabled when I'm in my development environment and working with the application. So I can directly configure it via a config map. Let's see if the application is working. I can use the Kubernetes CLI and say apply -f, and then point to the folders containing my Kubernetes manifest. And we have an error. Let's see. Resources. I misspelled something. Yes, there was a missing R. Perfect. So what I usually use on my local computer in order to monitor the workloads on Kubernetes is a project called Octant. It's open source and free, so you can install it on your local computer. We can see that behind the scenes, Knative deployed the application. So we have a deployment for demo service. We have a pod, a replica set. We can call this pod now. We have also an ingress resource created automatically. In order to get the URL, I can say kubectl get ksvc, and then get the URL through which my application is exposed. So now I can send a GET request to that URL, and I'll get back the message, Spring Boot on the cloud. So if you paid attention, you can see that this is not the value that I have configured in the config map. And the reason why is that we really didn't tell the pod or the container how to use that config map, right? We just deployed it on the environment. We have different ways to use that config map. For example, we can use it as a source for passing environment variables to the pod. In the container section, I can add in an env section. I can define environment variables using the config map as a source, but that's not the best way, because when we change something in the config map, the container is not informed if we use environment variables. Instead, if we mount the config map as a volume, then we get inside the container a notification saying, hey, this value changed. And then it's up to the application to do something about it. And basically to refresh the context and use the new values. So the first thing I want to do is defining a volume in this manifest. The volume will be called demo config volume. And the volume is created starting from a config map named demo config. Once I have the volume, I can mount it to the container. So I can say volume mounts, the name of the volume, demo config volume, and then the mount path. In this case is /workspace/config. And this is not magic. Workspace is the folder where buildpacks placed the Spring Boot application source code inside the container. So I know that it's this folder. And then I know that Spring Boot by default looks for property files from the surrounding context, depending on where the application is placed, and also in folders called config. So this is a conventional path. But of course, you can place it in a different one. If you do that, you can use the Spring config import and point to the to the different folder where you have mounted the config map. But by using this conventional path, I don't need to provide any extra configuration. So I can apply the changes again. So we can see that a new pod is being created behind the scenes. So if I call the application again, we should get the new message, or maybe not. So let's verify. So we might be hitting the previous instance. Okay, yes, Spring Boot on Kubernetes. Since we used a graceful shutdown and we were waiting for the previous instance probably to be shut down, but there were still some hiccups there. And the reason why is that we haven't told Kubernetes when an application is actually ready to accept new requests. So once we spin up a new container, how can Kubernetes know if the application is healthy and ready to accept requests? We use health probes. And that's the next topic. Health probes are a way of telling Kubernetes enough information so that Kubernetes can accomplish its functionality regarding orchestration and self-healing. We have two main states that we want to inform Kubernetes about. The first state is the liveness state. When an application is not alive, Kubernetes will restart the pod. It means that it entered the faulty state. It won't be able to recover from it by itself. So it's restarted because there's no way that the application will fix itself without any external intervention. The other state is the readiness state. If the application is not ready, then the restart won't help. So Kubernetes will stop sending traffic to the specific instance which is not ready until it's ready. And this is very useful in face of starting up the application. We have seen some hiccups. So a standard application takes a couple of seconds to start up. In those 2 seconds, we don't want to send any request to that instance because it's not ready to accept requests yet. And also, if at some point the application becomes momentarily unavailable, maybe because it's overloaded, again, we don't want to send traffic anymore temporarily. Otherwise, we would make things even worse. So these two types of information are provided automatically out of the box if we add the Spring Boot actuator dependency in the project. So we can directly inform Kubernetes about those two endpoints. We can do it from the manifest. So actuator exposes 2 HTTP endpoints. Now we inform Kubernetes which are the endpoints and how to call them. So first of all, I'll configure the liveness probe so that Kubernetes sends a GET request to /actuator/health/liveness. This endpoint is exposed by default when a Spring Boot actuator detects that the application is running on Kubernetes. So I don't have to enable it myself. And the readiness probe, HTTP GET. This time the path is slightly different. It's /actuator/health/readiness. And I can even configure this further. For example, I could have an initial delay period, 5 seconds, and then period seconds, so that every 5 seconds, Kubernetes checks for the liveness information. And I can do the same for readiness. Perfect. I'll update the application once again. We won't notice exactly how things will be different, but we're going to notice if we are doing a rolling upgrade or if we are scaling in and out applications. And overall, what we want to achieve is ensuring that the user has a seamless experience. We want no downtime. So if something is wrong, we really want Kubernetes to take care of it, for example, by stopping sending traffic if the application is not ready at the moment, and by restarting a container which is not healthy anymore by checking the liveness probe. We have covered several useful cases when we want to move to a production environment. So let's check the application. Once again, is starting Spring Boot on Kubernetes, but there is one use case that I haven't covered yet. So if we go now again to Octant and check this pod and check the logs for the demo service container, we can see that in this specific environment and with the current configuration, the startup time is 2.7 seconds. And this is fine if we are dealing with long-running applications, but if we are dealing with serverless applications, then we have a problem. Because since I'm using Knative, the default behavior is scaling pods to 0. So if for more than 1 minute, no request is sent to a pod, then the pod is destroyed. So we can see that in a few seconds, this pod will be destroyed. What happens is that when eventually a request arrives, Knative creates a new instance from scratch. And since it takes 2.7 seconds to start, the user will experience some delay before getting a response, which is not really a nice experience. So the pod here is terminating. So if I now send a request, once again, a new instance is created, but it takes a few seconds before I get the response back. This is not what we want if we are dealing with serverless applications. The solution in the Spring ecosystem is using Spring Native. So let's talk about that. Spring Native is a project, right now it's in beta, that aims at making it seamless and easy to compile Spring Boot applications into native executables based on GraalVM. By doing so, we can achieve different benefits. First of all, we achieve an almost instant startup time. Usually it's under 100 milliseconds. And it's perfect if we're dealing with serverless applications because we want the scale to 0 feature to work well. Then we can achieve instant peak performance and also a reduced memory consumption because we are moving a lot of the computation that on the JVM happens at runtime. We want to move it at build time. So we increase the startup time, we reduce the startup time and reduce memory consumption. But at the same time, since we're moving a lot of computation at build time, we have a slower and heavier build process than usual. Also, at this point, we don't have the same amount of runtime optimizations in GraalVM as we do for the JVM. But this technology is really catching up quickly. So I'm expecting a lot of exciting results from newer versions. So for our example, I have created the exact same application that we have just worked with, but I have added the Spring Native dependency to it. From here, so it's the same setup as earlier, I can add the Spring Native dependency. You can see it's an experimental for now, beta mode. And just by doing that, I can achieve a native executable out of the box. So I don't have to change anything in my code. Let me show you. I have in my editor a separate project. I called it Demo Native, but it's the same exact code that we have in demo service. The only change is in the build Gradle file, where we have 3 extra additions. The first one is the Spring Native plugin for doing ahead of time compilation. So I talked about moving a lot of computation from runtime to build time. This plugin takes care of that. Then we have the GraalVM Gradle plugin, which lets us build native executables directly on the local computer. So I will get extra tasks, like, for example, native build and also native test. So I can run tests on a native executable. And then I get extra configuration for the boot build image task. In particular, using this environment variable, BP native image, I can use the same tasks as earlier. So doing boot build image. But because of this environment variable, I won't get a JVM container as a result, but I'll get a GraalVM native executable. So by using that task, I don't have to install GraalVM on my computer, which is also a good idea right now because it's the process, it's heavier, it takes a lot of resources. So it's a good idea to move that part to an automation. So for example, on your CI/CD pipeline, which is also what I did on my GitHub project for this source code example. I have GitHub Actions running these tasks to build a native executable, and then it's published to Docker Hub. I have created the Knative manifests already. They are really similar to what we have done in the previous example, but now the application is using the demo native image. So let's first uninstall the previous one. So I can say Control delete, and then we delete the previous application. And then I'll deploy the new one. Yes, that's wrong. Control. So maybe I can spell this time correctly. Perfect. So we have the application now deployed. Let's have a look in Octant when it's up and running. There it is. So now we're gonna use a different URL, which is one of the features that I really like from Knative. I get directly the URL I can use instead of using port forwarding or defining an ingress myself. There it is. And now I can send a GET request. And oh, the application is not ready. So you can see here only one container out of two is ready. One is injected automatically. I don't control it myself. The other one is my container. So let's have a look at the logs. Demo native. So the first thing to notice here is the startup time. Now we went from 2.7 seconds to 0.0 seconds. So we're talking about 66 milliseconds, which is amazing considering that I haven't changed anything in my code. I just added Spring Native as an additional dependency. And we can even calling the request. For some reason, it's not ready. Let's have a look. Nice live debugging. So let's verify that the manifest is correct. We have the right image. We have the volume. The config map is named demo native. We have also different message this time, Spring Native and Knative. Yeah. Exciting. So what happens if I delete one? Oh, okay, so probably is the initial delay seconds. Let's try with 10 seconds. Let's apply the changes and see what happens. Well, we gave it a try. Sorry about that. But my point was that now that we have almost instant startup time, we can also support a serverless use case. And having Knative in my Kubernetes platform, it's really a great thing to have in our toolbox. And that's the end for today. We went from the development phase, we used Spring Boot, and also at the end had an initial look at Spring Native to build cloud native applications, which are also good for a serverless use case. We use cloud native build packs to containerize the application into container images, both JVM images and native images, relying on GraalVM. And finally, we deployed the application on Kubernetes. And we can we need to pay attention to all the different aspects that I mentioned. We can run it directly on Kubernetes, or as I demonstrated also on Knative, so that we have better abstractions for developers and also extra functionalities like scaling to zero, supporting serverless workloads, and event-driven applications. thank you very much for following. I really wish you a great conference. And right now we have a few minutes left. If you have any questions, I'm ready to answer.
Hey, Thomas, thank you very much for this session. Very interesting. We got one question from Scott who would like to know how soon Spring Native will move out of experimental into general release.
Yes. So last September, during the Spring One conference, it's been announced that Spring Native will remain in experimental mode for the current train release of Spring Boot and Spring Framework, but it will be merged in the main project in the next major release. So with Spring Framework 6 and Spring Boot 3.
And that's all we got in the chat. But remember that you can always reach out to Thomas on our tool Workit later on. Thank you very much again, Thomas. I wish you a nice end of day.
It's been a pleasure.